universal laws, standing tall. From the atom to the cosmos, we rolling deep, grazing up the stars, no time to sleep. Black holes and supernovas, concepts we unfold. Brain power heavy, yeah, that's Dr. Gold. Dr. Gold dropping gems, knowledge raining down. Actual education making scholars all around. Perpendicular minds, angles sharp as ice. Maths and physics, yeah, the future's real nice.
What's up, everybody? All right, let's see if YouTube wants to work today. Do you think YouTube chat wants to work today? No. Let me see test. Come on, girl. Yes, it is working today. Wow, YouTube chat works. We're so happy. I'm so happy. Anyways, yes, welcome. I've been sick for the last 2 days, unfortunately.
Oh no.
Who could have known that you'd get like a sinus infection from being in a pool with a bunch of other random people and just partying and drinking for like 2 days? Who would have known? Who would have known?
That's why you're supposed to drink orange juice with your vodka.
I was drinking like electrolyte drinks and everything. I was drinking a lot of stuff. I think honestly it is just like I did swallow some pool water at some point, and that was probably a very bad idea. Because God knows what's in that pool.
Did you get the Brondo?
Brondo, it's what plants crave. They love the electrolytes.
It's got electrolytes.
No, it's this drink. It's called Electrolyte. It was too funny, dude. I just kept ordering these like on repeat. Here it is, Electrolyte. Yeah, it's like an electrolyte drink. It's like Pedialyte and like Gatorade-ish, I guess, you know? Without
Honestly,
all the sugar.
I really don't think there's a point in like drinking those things unless you're like doing a lot of exercise.
I mean, it was 110 degrees outside, so like I think the heat is the main reason why I was doing them, because you do lose a lot of electrolytes, right?
What's 110 in scientific?
Oh, that's a good question. In the Kings. Wait, didn't the UK used to use Fahrenheit for a while actually?
Yes.
Right? It was one of those things where like it changed. Ah, man. Or something. It's like you guys used to use pounds and then it switched. Okay, 43.3 degrees Celsius. Yeah, 43.3. Yeah, that's really hot.
Didn't I tell you this? How we still have sort of a mixed system anyway?
Yes, yeah. Sorry, that's what I'm thinking about. Sorry, you are right. Yeah, what's the mixed system again? Sorry, it's like pounds and like feet or something. Or, I don't know.
If I'm cooking, it's ounces, pounds, and stones. If it's people, it's pounds and stones.
Interesting. Yeah, but it's not kilograms.
Miles is miles.
Right?
I rarely count in kilograms.
That's crazy. I feel like the EU is all in kilograms, right? They always say like how much you weigh in kilograms, right?
Oh yeah, the Germans said that everyone has to count in the metric system, and we went no.
No. Absolutely not, Germany. Not this time. So I just Erica is with a K, right? So they're like, yeah, count everything in kilograms.
So that's the joke, because the Germans couldn't win the war twice, so they they conquered us with politics.
With politics. Okay, there you go. Sneaky wins. What's up, Jeff?
My name is Jeff. Build, I don't know, what would you call it? Like a federality, like the US has.
Oh, we're a republic, I think, technically. Or Federation of States? What is the US? What are we?
Yeah, it's a republic.
Yeah, is the United States a republic, a constitutional federal republic, or what was the other word we said? A republic or a federation?
I said federality.
Oh. Yeah, I'm just curious. Like, sorry, what's all the difference between these things? Okay. A republic. Okay, so both. You right. Jeff was right here, and you were right as well.
My name is Jeff.
The United States is a federal republic. So republic describes how the political authority is structured. The country is governed through elected representatives rather than a hereditary monarch. Okay. Federation describes how the governmental power is divided. Authority is constitutionally shared between a federal government and 50 state governments, each with its own. Okay, cool. France is a republic, but not a federation.
Yeah. I don't know why that was the comparison, though. It's like, this is a republic, but as opposed to having a crowned monarch. Well, yeah, but our monarch doesn't really have any power anyway, because we have a parliamentary democracy.
Yeah, they say Canada is a federation, but not a republic. So Canada has states, but technically is also a constitutional monarchy. Yeah, there we go. And then, like the UK apparently is also like is a unitary constitutional monarchy. Oh wait, which means it's not a republic and it's not a federation. It's none of these things.
No, because the UK is made up of different countries rather than different states.
Oh man.
With different races of people that speak different languages, but we all just speak English as a point.
Okay. Yeah, it says here, one wrinkle is that the UK can sometimes look federal because Scotland, Wales, and Northern Ireland have their own legislatures, but legally that power is devolved. I don't know what devolved means. Rather than constitutionally sovereign in the way the US are. So I guess it's like they give it to them, but it's not guaranteed. Is that kind of what it means?
I think it means the monarchy still has to technically sign off on it. It's a checks and balance system. The parliament drafts something and it has to go through whole stages. And then when it reaches the final stage, the monarch has to sit there and say, well, yeah, you can, or no, I don't think this is the benefit of my people. No, you can't do it.
Oh, interesting. Oh, so the UK, so the queen or the king still has like the final say.
Yeah. Interestingly enough, that's the only checks and balances that you have, and it's not sufficient, to be quite honest.
Oh, interesting.
But think about it, it's only one man. Anyone can be born.
Yeah. Anyone, yeah, exactly. Right, yeah. And that person could be crazy. They could be like the Mad King or something. Oh, Game of Thrones here. The Mad Queen or something. Okay, cool. I love learning all these like little random things. Well, history's fun. Nice. What is this Brescals? What is this question Brescals submitted? Sorry, but what? It's a difficulty 2 out of 10. What did you do? What did you do to game the system? But you gamed it by just making like a cute little.
No, I actually wasn't gaming it. It was a question I did, and I didn't find the Fourier series. I just wrote down the function.
That's too funny. Yeah. Because look, you submitted at 5:05. Kaushik Techno, what's up, Kaushik Techno? Submitted at what's up, Scotty? Scotty Tobin. Wait, is this the kid I tutor? Toby Scott? Or are you putting your name backwards? I did used to tutor a whole family of people, the Scotts, and there was a Toby in there. So that would be a useful username, I guess. Anyways. Oh, but now Kaushik Techno is starting to upvote their question. Yeah. Okay.
He also submitted too, so like the points that are being earned, they're pretty close.
Yeah, right. He submitted 2 minutes early. I think Kaushik technically submitted at like 6 a.m., but I have the bot now go through and like 10 minutes before the stream, I just have it clear everything. Because, yeah, otherwise it's like thousands of votes. Like, we can't have that. We can't have thousands of votes. This isn't... I don't know. I want to insert some joke about LA and like vote counting or something. Where we just go to the homeless and we just pay them to vote for us.
I heard about that.
Yeah, there is like some legitimate concerns there sometimes. Because, yeah, I don't know. It is a bit weird. I started to put my tinfoil hat on a little bit about voter fraud. I'm just like, well, there's some kind of like weird things happening, so I don't know.
To be fair, though, it is kind of a semi-legitimate vote. Like, I mean, I personally...
to get a homeless person to vote for you if you pay them?
Yeah. I mean, to a degree, it's like... you know, and
yeah.
Either way, they could just, like, not
They could
vote
say
for him anyway.
yeah, they could go in and
Like,
not
they
do the
could.
vote. Right, yeah, no one's
Yeah,
forcing them to
exactly.
vote. Well, actually, no, I think where this comes in is they have them do the mail-in votes, so they watch what they like put in for the mail-in vote. That's the
Yeah,
difference.
see, that's
sketchy.
I think is
Yeah.
sketchy. But,
Yeah.
you know, if you gave a homeless person $10 and told them to go into the voting station,
Right, they can go do anything. Yeah, that's
strongly insinuated vote for who I want you to vote for.
but I can't check it. But yeah, I think
Yeah,
collecting a
yeah.
bunch of mail-in ballots, that's where this starts to get a little sketch. Which
Yeah.
It's kind of
Then
funny
I-
how you two are absolutely downplaying this. It's like, even I know that's a felony.
yeah, I know.
No,
Dude,
I
don't
mean, I know
dude.
it is, but
People just get away with it.
You know.
It just doesn't matter, you know. It's just I don't think it's that bad of a felony. I think like it's like a couple days in jail or something. Right? Anyways.
I mean,
yeah.
the U.S. government really doesn't prosecute anything these days. So, like,
Right, yeah.
the DA would probably just be like, "Yeah, fuck it, I don't feel like being
Yeah,
like
just
this.
just stop doing that.
send you on
Right.
your way."
It's like stop doing that.
I mean,
Roy-
maybe just, like spend the night in jail, and then you know they'd be like, "Yeah, we're not going to persecute. You're good to go. Send you on your way."
Catch and release, baby. Catch and release. What's up?
Here's something new for you to look at.
What do you want?
Jugad. Tell everyone about Jugad.
Sorry, Jugard? Sorry, what is it? Jugard?
Jugard.
Hey, what's the Jugard? Excuse me, what?
How do you spell it? G-U-J-U-G-A-A-D. I think.
Jugad. Oh, Jugad. Okay, all right, let's go see it. Okay, very cool. All right. Jugad is a colloquial South Asian term for an innovative fix, workaround, or flexible approach to a problem solving that uses ingenuity and limited resources. Also referred to as like a hack. That's cool. It's a
Or in
South.
the modern case, it just means putting credit card skimmers in gas stations.
Oh, interesting. Oh, are you going to say
Have
that?
you
like,
noticed how there's been a huge prevalence of that in the
yeah, the skimmers. Yeah.
California actually? I think.
Yeah, but these days you just do tap to pay. You just don't even deal with no one like puts their thing in anymore. It's all NFC.
Right, which credit
Yeah.
card skimmers still work under those conditions.
Do they?
I mean,
do they
there's-
still work with tap to pay?
Yeah, and there's other ways to get like. But
See,
like I
there's-
knew a dude, he would go around.
I thought that
with
stuff's like
Flipper
encrypted.
Zero.
I know. Well, the Flipper Zero you can do whatever with. Yeah.
Well, what he would do is he'd go around and it would send out a signal. You know how sometimes you'll get, like, it'll say like, "Oh, connect to Apple TV" or whatever.
Yeah.
He would go, it would send a message to connect to Apple TV, but there wasn't actually an Apple TV.
Yeah,
What it
that's
was
this thing.
actually doing was it would take all of the credit card info and everything that you had in your Apple wallet
right.
and take everything off your phone and would use it to buy his lunch.
Yeah, that's the new thing here. The Wi-Fi pineapple, I think, is the one I've heard about that's now been in the news because a bunch of people coming back from DEF CON like started turning theirs on like a Delta flight, and they had to like land the plane. they're like, no, dude. Like they're trying to spoof the Wi-Fi on the plane. That's like a huge FCC like offense.
That's an extension of what's called a man-in-the-middle attack.
Yes, man in the middle. Exactly. Yeah. You pretend you're somebody else, and then you just take the packets. It's cool though. I want to go to
Never
DEF
attached to
CON.
unsecured Wi-Fi.
Never. Yeah, exactly. Yeah. Or Wi-Fi. Well, I think that the crazy thing about this is it'll spoof like the SSID of trusted networks to the point where like it'll still like accept the connection. Like phones will think it's legit and automatically connect to it. Like especially on something like a Delta flight where everyone has their phone automatically connecting to like whatever Delta Wi-Fi is. That's the problem. That's the big problem with this is everyone else already has that SSID in their phone like as an automatic thing if you've flown on a plane. And so everyone was getting like basically like bopped by this thing.
Well, you know my opinion on this. If you're going to use Wi-Fi, fuck it. Just let them get scammed.
Just let them get scammed. Sometimes there's
Nobody
only choice
uses
we gotta do.
Wi-Fi. There's a reason why people who have money don't use Wi-Fi.
Yeah, I just don't connect to like airplane Wi-Fi. I just sleep.
You just sleep.
I just
do you
drop
raw
the
dog
tray
it?
table and go to
Do
sleep.
you raw dog your flights?
Usually, yeah. I mean, I just like send it. I end up falling asleep.
Yeah, I usually
Airports
just
stress
get,
me
like,
out, so by then I'm
Yeah.
tired. I want to sleep.
I usually just get
People
like really
walk
fucked up
slow.
before my plane.
They like
Yeah.
fucking do all that. So I'm just like, yeah, I'm just gonna knock out and
Yeah.
hopefully not have a baby crying.
Yeah, that can be bad. Yeah. Okay, let's see. We got some good questions. So here, let's do some math and science with you guys today. Let's start the stream. Cool. All right, sorry, my voice is gone. Welcome everyone to Actual Education Office Hours. My name is Dr. Gold. This is the stream that helps you out with math homework and science homework and all sorts of fun stuff. Let's see what we got on the queue today. We got breasticles, remote to shine, Cowshy Techno on 2. Cool. Let's go pick one. Let's go pick a question. Let's go gamble. Yes, thank you.
Let's go gambling!
Bum, bum, bum. Wow, breasticles! Your difficulty 2 out of 10 question wins. Don't worry, Cowchick, you'll probably get picked next.
I mean, it was like 50-50 between us. He had like 140. I had
He
like
did have two. He did have
so.
2 entries, yeah. Which at least that means the code's working because it's not. It's supposed to like kind of balance that. You don't get like double shots for 2 entries and stuff. Okay. So, oh, this is a Fourier trend. Sorry, this is taking a square wave, no? And just writing it.
Yeah, this is pretty much a square wave. Yeah.
This is cool, actually. Yeah. Okay. So yeah. So you have from 0 to pi. Let's see if I remember how to do this. Honestly, I don't. Yeah, I might. From 0 to pi, it's equal to 1. Cool. Just like that. And then from negative pi to 0, it's gonna be equal to negative 1. Ooh, can't draw straight lines today.
Am I going mad? I thought a square wave could never be less than 0.
No, it can definitely be less than 0. I'm pretty sure. Yeah.
Yeah, I can.
Yeah. Square waves usually oscillate between like a negative voltage and a positive voltage. I think. Well, here, let's get a picture of them. Yeah, you're right.
I mean, technically, you could just
put an offset on it.
Anything on a from a Fourier series. You could do a square wave, a saw wave.
This is usually it. Yeah. No, well, okay, maybe sensation's a little bit right here because see how it goes from like 0 to positive.
Yeah, well, so it depends on like what your application is.
But Wolfram says
it can be anything.
Yeah, well, I mean, because voltage is also relative, right? It's just what are you measuring it relative to? Yeah, you're right, sensation. If you're measuring like relative to ground, like there's probably no way to be like negative. But yeah, you're right. You know, good point. Good point. But anyways, these are a bunch of different types of waves. Was a glitch for YouTube comments in the last? Yeah, it was the last year. I can see your chat right now, Kaushik. You're good. I see you. Do you see you? You see you in the chat. You're good. Anyways, yeah, these are a bunch of different types of waveforms, which are really cool. If you like music production, these things are super dope. So like sine waves make cool little like soft sounds. Square waves make what I think are like boxy sounds, and then sawtooth waves make like really harsh sounds. See if we can like pull some up actually. Let me see like waveform generator. I mean, I could just pull up Ableton right now and just show it, but I think there's probably an easier way. Yeah, here we go.
In that respect, we're talking about music.
Yeah, what's up?
The NES.
Yeah, the NES. Yeah.
Do a deep dive after this into how the NES made its sounds and its music.
Oh, that's cool. Like 8-bit music and stuff.
Yeah, because obviously this is way before transcoding. I'm sorry, I'm half asleep here.
You're good. You're good.
You basically had to pump a set of instructions through a chip, and it made sounds. And one of those major sounds was a square wave. Oh,
interesting. Yeah. And the square wave here.
It can wait until after. So.
No, you're good. You're good. 1 sec. Let me. There we go. So yeah. So a square wave. Here, I had to turn the music off for a second. This is like a square wave. Ooh, it's kind of annoying. Can we get like maybe a nicer tone? Let's do like 220. There we go. It sounds kind of like boxy to me, like a square wave. It sounds almost like hollow, like a I don't know. I'm trying to think like a flute maybe. The music I'm playing was sine waves, yeah. So that's a square wave. This is a sine wave, which sine waves sound softer. So notice how that's like a lot softer. What's up, Manny? Yeah. So yeah, that's a sine wave. And then here's a sawtooth wave. This is like kind of like It's almost like a mosquito. Triangle wave. Triangle wave, I guess, is kind of in between a sine wave and a sawtooth. Oh, I see. Yeah, and then this is a square. Anyways, that's just cool. It's just different in music. Like these different types of waves, these waveforms are super important for creating different sounds. So yeah, I invite you to go like check them out. Yeah, hertz is like an FPS. You're right, Xeroxy. Yeah, hertz is how many cycles per second, which you can think of as like a frame rate for sure. Yeah. So like 440 hertz is 440 of those sine waves happening per second. And that corresponds to what I think is usually called like concert A. So if any of you guys like tune in like an orchestra, you usually tune to 440. I think it's like A2, maybe A3, maybe it's A4. I think. Like the Battlefield 6 free trial, which is coming the 18th. Oh hell yeah! Nice, yeah. Come play Battlefield 6 with me. I love Battlefield 6. I haven't played it this week, but yeah, Wake Island's coming out. It's gonna be great. Okay. Anyways, so yeah. So these are the different types of waves that can get created, and the one we're specifically talking about here. Yeah, this is I guess technically there's kind of like a discontinuity between here, but
yeah.
If you were to repeat this a bunch of times, right, this would create a bunch of like square waves, or yeah, something like I don't know. Yeah, I need the other line, but yeah. Okay, cool. All right, so yeah, you might be asking yourself, well, how do I produce a wave that looks like this? Because it's kind of hard for electronics to go from here to here like instantaneously. Technically, there's always kind of like some sort of delay. And so one way to do this is to compose this of a bunch of like sine waves that just have really nice phases and stuff, and it just works out. And that's going to be what is a Fourier transform, right? That's what we're doing with this?
Fourier series, yeah.
A Fourier series. Okay, cool. Okay. All right, yeah. And so this is from negative pi. All right, I feel like the equation for this is, if I wanted to this is y of x is what you're saying. I think this is like y of x is equal to the sum from like n equals 1 to infinity. And I want to say it's like sine of like n pi x over 2 pi, maybe? I don't know.
You're
close?
pretty close. So it's from 0 to infinity, and it's just nx.
Okay, it's from 0 to infinity. But wait, the general formula, right, is it sine of like n pi x over a, right? Where this is the width, right?
Yeah, that sounds familiar.
Or like, yeah, so that's where I'm like, I think a is then equal to 2 pi, no?
Oh, no, it's a, so a is on your interval, it goes from negative a to a. So a is 0
Oh,
to
okay,
a.
it goes from negative a to a. Okay, yeah, cool.
Yeah.
Is this a math class? Oh, no, this is just a live stream where you can ask whatever math or science question you want, Roger. You can ask physics too if you want, yeah. We have a website for that. This is so fun. I always love this time of the year because now students are starting to go to school and they're like, oh, this stream is useful. So anyways, but yeah. What were you going to say, Sensation?
I was just like, it immediately sounded like, is this Krusty Krab?
This is the Krusty Krab Cafe. But anyways, Roger, yeah, no, this is just like kind of a free live stream where we just like, we help people with math and science questions. If you want to submit a question for us to go over, there's a website here, actualofficehours.com. You just drag a screenshot in and we just do it during the stream here. So you can do physics. Physics is cool.
Yeah, I forgot.
Like, what's up?
They just reminded me. It's A-level results today.
Oh, it's A-level results.
A-level
that is what
results
Shush said. Shush, how'd your A-level results go? What's up? Tell us how your results went, Shush. How'd you do? Give us.
You know they got an A-star.
Like, Shush got an A-star, yeah, of course, right? Name like that, Shush. Shush, you gotta have an A-star.
The amount of people that were out on the piss tonight because it was the A-level result today was mental.
Oh, is this like the day to go get like fucking drunk because you're like, I got my scores in, and like you either drink because you're happy or because you drink because you're sad?
No, I think it's just because school's finished and you're finally going to university, or not, as the case may be, and then everyone just gets hammered. And people, 18-year-olds running around the marketplace shouting, "Duck Warden, save me!"
Duck Warden, save me.
It's like, what am I gonna do? Leave me alone.
You are the Duck Warden. You didn't know that said I failed my A-levels math, so I'm sorry. Oh, thank you for the star, Roger. So yeah, if you failed your A-level maths or you didn't do well in it or you wanted to do better, make sure to like, subscribe, and whatever this channel because we can help you out for free. It's all for free. So yeah, come get better at math with us. So okay, let me go back to Rascal's question here though. Sorry.
The cost
All right,
is
so
the occasional abuse from me. Suck it
and
up.
yes, yeah, you get the occasional stick from Sensation. Okay, so sine n pi x over a. This is the general formula, I think, for a Fourier transform of a square wave.
You'll want a bn in there.
Right, and okay,
on the outside.
and then we got to solve for the coefficients. Wow, what's up, Don? We just got a factorial rate, dude. What's up, Don? Shout out to Don. Shout out, Don. What's up, broski? Nice. We're doing Fourier transform stuff right now. I was talking. I think Don and I are also part of a group. We're gonna review like math videos next week. So there's this big competition called the Summer of Math Experience. Maybe is what is it called? But it's this YouTube competition hosted by Three Blue One Brown, which is a very, very famous YouTube channel for like math videos, and people try to make like cool explanation videos to like win a prize. And there's a community judging period that Don and I are going to be a part of, doing some streams next week. I will announce that in Discord. But Summer of Math Exposition, that's it. Correct. Yes. Yeah. All good. W rate. Yeah. If first you don't succeed, try again. Yeah. Okay. Illegitimate non-carbon. What?
Illegitimate non-carbonundrum. Don't let the bastards get you down.
Don't let the bastards get you down. I agree with that. That's a great one. Expose yourself during Summer of Math. I'm gonna expose myself as a math fraud, honestly. I've seen some of the sample videos from last year, and I have absolutely no clue what they're about. They're just like really high-end topics. I'm like, what the fuck's going on here? I'm gonna try to pick some easy ones to go through. All right, so here we go. So these are the coefficients, right? And then these are the sine waves. Cool.
Yeah, and this formula only works for
square waves, right?
well, no, it works for any odd function.
Oh, for any odd function. Oh, that's very cool.
Yeah. Since sine is odd, well, I mean, the short explanation is since sine is odd, we can simplify it down to just be.
And for
odd.
those in the crowd that don't know what an odd function means, odd function means like it's like, I don't know, it's like a mirror image but flipped on the left and the right. So like, for instance, this is an odd function. See how like if I go this way I'm up, and if I go this way I'm down. The technical definition for this is like f of x is equal to negative f of x, negative f of negative x. But I don't know, sometimes this like confuses people. So this is an example of an odd function. This would also be an odd function. Just a straight line like this. Yeah. Correct. Physics is my specialty. Okay, cool. All right. So A defines, so this is for from negative A to A, where A in this case is equal to pi, right? So then I'm guessing this is the hard part, right? You didn't just give me an easy question of just like write down the formula. Is B of n is the hard part, yeah?
Hard being relative, it's honestly like not that hard of a question.
Okay.
In general,
all right.
But
That's okay. Let's go figure it out. Okay, so this is gonna be sine of just nx, I guess, right?
Yeah.
If a is equal to pi. Yeah.
Mm-hmm.
Cool. All right. Then how do we figure out b sub n?
So b sub n is going to be 2 over pi, and then it's going to be the integral from 0 to pi of sine of nx dx.
Okay. Whoa. Wait 1 sec. B sub n is equal to the integral from like 0 to a. So in this case 0 to pi, and then it's sorry what?
There's also a 2 over pi out front.
Okay.
Coefficient.
also a 2 over
Because
A.
technically we do.
We got to
from
normalize it or
0
something.
Yeah.
Okay, cool.
And then it's sine of nx. More generally, if we look at the general formula for a Fourier series, technically what we're doing is we're doing the inner product of the function that we're trying to find and our sine of nx.
Okay. And I guess the function here is just a fucking straight line, right? That's the funny part.
Exactly. It's just one.
Right. Yeah. So the function is just 1 times this, basically. Learning CAD software. I don't know what Onshape is. I've used AutoWorks and AutoCAD, and SolidWorks. Best way to learn CAD software is to do CAD software. Yeah. Just find a project. Find some dumb shit you want to like try to CAD up, and just do it. Using a mouse is a pain. Correct. Okay. Okay. So here we go. So this is, and it's dx. Sorry. Right. Yeah.
Yeah, it's dx.
Okay, so this is not too bad of an integral. So this is integral from 0 to pi. This is integral of sine is negative cosine. So negative cosine of nx, and then because we had an n in there, I have to do over n. And this is from 0 to pi. Okay, I think I'm good so far. So 2 over pi, and then we're going to say negative cosine of pi x. Oh, let's take the n out as well. Sorry, it wasn't dx. It wasn't dn. It was dx. So this is n pi, right? And then there's an n underneath here. And then minus is going to be plus cosine of 0. Okay. This is just going to be 1. And then cosine of n pi. Well, this oscillates, no? Oh, wait, no.
Yeah, that would be a...
This oscillates.
Cosine of n pi is
negative 1 to the n. Yeah, right? Yeah, this is negative 1 to the n. Reason for that, again, just to show real quick. If you have cosine always refers to, like, what's the adjacent. So this is cosine of 0, which would be 1. And then if you were to, like, come around to cosine of pi, which is cosine of 180 degrees, this would now be negative 1. And then cosine of 2 pi would be 1, 3 pi, negative 1, and so forth and so forth. So just like it keeps oscillating around. So that's negative 1 to the n. Please solve the equation. Abram, if you want to take a screenshot and throw that into our website, I can definitely get on the list. I can't really solve questions from chat directly because there's like too many people in chat. All right, negative 1 to the n. Oh, wait, sorry. This is negative 1. Wait 1 second. Let me get this right. Sorry. Yes, negative 1 to the n, and then it's plus 1, right? Like that. So this is going to oscillate between...
There should be a negative on it. It should be 1 minus negative 1 to the n because of the negative from out front of the cosine.
You're right. I did forget this one. Yeah. Sorry, there's 2 negatives.
No, not on the 1. On the negative 1 to the n.
You mean there should be another negative here?
Yeah, because cosine of m pi is negative 1 to the n. And
got you. And then we have we have negative cosine. Oh, okay. So
cosine.
this was correct. I just forgot it. Okay.
Yeah.
Okay. So yeah, sure. 2 over n pi. 1 minus negative 1 to the n. Yeah. Okay. Cool. What do I do with that? Because I mean, that's either going to be
you just
2
throw
or...
that into the series, and then you have your series.
Okay, cool. So then it's just this. Fembox says x equals 1 works. You should always check x equals 1. Anytime you have any sort of like equation where they're like solve for this, I always say like check one of the easy roots. Okay, so we put this in. So I'd get 2 over pi, and then like whatever, put this over n, just make this pretty. And I would say this is 1 minus negative 1 to the n. Yeah? Cool. Great question.
And on that note.
And on that note. Ooh, Super Mario.
And
Okay,
I
here
also
we go.
sent the generalized Fourier series. That's where the coefficients come from.
Oh, this is super cool. So wait, these are waves that the Super Nintendo uses. All right, so these are square waves. That's square waves that are, I guess, just have like amplitudes that like boost up and down. That's cool. That's like a sidechained one, I guess. And let's see. This is okay. So it was a bunch of square waves. And then wait, let's see the triangle waves. Oh yeah, and then if you put them together, you get like some fun interference. Oh. They use the triangle wave for the bass, I guess. And then... Oh, the noise is the fucking snare and the hat, dude! I didn't realize that. That's so cool. And put it all together, this is what you get.
You can tell this video too is like actually... They were actually using an oscilloscope in the PCB, because you can see the square wave oscillator, not oscillating,
yeah, you can see the attenuation. Yeah, there's a ringing effect on it. Super cool. Okay. So yeah, there you go, guys. If you wanted to know like why all this like math shit is useful sometimes, like yes, these types of waves is how your Super Nintendo, well, you don't have a Super Nintendo, but how old school video games used to make music and stuff.
But it still has a modern point to it. Crying out loud, I really am half asleep.
No, you're good.
It still
late for you.
teaches you about signals.
Yeah, exactly.
It uses a lot of it in signal analysis and signal processing and like supercomputing. It's also just generally it's helpful because technically we can represent literally anything for any function as a Fourier series. And then there's some other stuff to it. Like technically what we did is we basically created a basis for these, I guess not the solution space in this case, but for the Hilbert space that function is in. So we've made an orthonormal basis, and so anything in that Hilbert space can be represented.
This is where we're going far off, dude. Wait, what? Hilbert space, dude? Why?
Yeah,
why are we talking about this funny shit, dude? What?
Hilbert spaces sound like worse than they are.
Sounds scary,
dude. It's just a vector space. It's a vector space with values in it.
Yeah. Narosky says, geometry is the baseline you can use to tell if someone has innate mathematical talent. Let's do some geometry. We'll submit some geometry if you want, dude. You want to? Here, let's... Abram's a new user and found us on TikTok. And so I will jump you to the front because Kaushik, I do want to do your questions, but they might take a while and Abram might lose the attention span. So let's mark Abrams as the one we're gonna do. Congrats, Abram. Solve the equation in real numbers. See, this is where I don't know if there's a thumbnail to this, so this scares me. This is one of these. I feel like it looks like it should be easy, but it's not gonna be easy. Like someone just found something hard for me to do. Okay, let's see. All right, solve this. So we have 2 times the cubed root of 2y minus 1 is equal to y cubed plus 1. Oh, Christ. Yeah, one works, but maybe there are a bunch of other solutions. Yeah, this is one of these things where to honestly like solve this, I would just throw this in a calculator. I would just say like, hey, y equals this, and just find out where they intersect. Yeah, but if you like actually had to do this, I mean, it's going to turn into a really, really messy polynomial. I would like move this 2 over first. Or maybe not. Well, yeah, maybe I would. So, and then I would rewrite this like in exponent form. I'll say this is 2y minus 1 to the 1/3 is equal to 1/2, then y cubed plus 1. And then in order to get rid of, I don't like this. This is ugly. I would then take both sides and raise it to the 3rd power. Oh, what's up, Narosky? Yeah, come on. Narosky, do you not have permission to just come on the stage, dude? Did I not make you a stage moderator?
Yeah, but I think it's rude if I just hop on and start.
No, please, dude. No, you're fine. You have VIP access. Don't worry. You can hop on whenever you want. Yeah, you're good, dude. Okay, so do you see something unique about this, Narosky, before I like go down this like terrible rabbit hole?
I mean, I can let you try. You do have like an hour left if you want.
He's like, I'll let you flounder if you want, dog.
Yeah,
okay.
I mean, I can give my input if you want, but only if you think I can help you with this.
Well, I know you can help me with a lot of things. Maybe, am I going about it the right way? That would be a good question. Or is this the the dumb brute force way to do it?
Well, no. As long as you denote that cube root to be something, I think you're fine.
Okay.
You can just brute force it. It's not that difficult. As long as you denote the cube root of 2y minus 1 as something, it's not gonna take that long.
Oh, okay.
In
Okay,
my
so
opinion.
this is an interesting. Okay, so instead of leaving this as a thing, you want to call this whole thing just like a single thing. I actually like that idea. This is actually okay,
Yeah.
so let's you know what, this is similar to what you showed me how to do last time with the kind of the pseudo Newton's method, where you're like, oh, just have the thing like equal to each other. Yeah. Oh.
It's something like that. Yeah.
That's cool. Okay. So let's call this. Let's call the 2y minus 1 to the 1/3. Let's call that equal to. Let's call it equal to x, I guess. Sure.
Yep.
So now we have 2x is equal to y to the 3rd plus 1. Okay. And then this, like, I know kind of contains a y, I guess. So,
You can just infer that x cubed plus 1 is 2y, and you'll have a system of equations.
Oh. Okay, wait. Okay, so this is true, right? Because we substituted in. And you're going to use the condition I set, which was that x cubed plus 1 is equal to 2y.
Yeah, this is something you should know, like anybody should know when you're doing substitutions in various problems. If you're adding variables, it's very useful to create new equations, because for each variable you add, you will need another equation for that system of equations to make sense. If you understand what I'm saying.
For every unknown, you need another equation, right? If I have two unknowns, I need two.
Yeah.
Okay.
It's like what I was showing you with that that fifth order nonlinear.
Exactly. Yeah, the huge, massive one, and you said like, oh, we can just turn it into a system of differential equations. Wow.
I swear, I know all you Americans love saying system of equations, but that just really boils my piss.
What do you guys call it? What do you guys call
Simultaneous equations.
Simultaneous. Yeah, I guess it is simultaneous. You're right. You're right, technically.
It's weird how that specific term is the only real American term that boils my piss.
Okay, does this just tell me that x equals y at this point? I feel like it does.
I mean, you can just infer that. Yeah, it is.
Right, because like it's literally like the same shit, right? I have like
because this is because you can subtract them, like you can subtract the two equations, and you're gonna get that after factoring, one term is gonna be x minus y, and the other term is gonna be greater than 0, and so the only solution is x equals y.
Oh, okay. So yeah, let's show how that is actually. Yeah, I agree with that. Okay, so let's call this equation 1. Let's call this. Dude, this is so cool. This is such like a unique ass way to do this. Okay, fine.
I can show you another way that I personally wouldn't have done this because I know of another way, but I'm gonna show that.
Let's show the next one next.
after this.
Yeah, I want the even faster one. Okay. Okay, and then what we're gonna do is we're gonna subtract these two.
I think the even faster one is Wolfram Alpha.
Yeah,
literally any sort of computation.
Yeah, okay. So this is 2x minus y is equal to y cubed minus x cubed. And then this is a difference of cubes. And so I know this is... Is this y... It's y plus x, right?
No, it's y minus x times something.
Okay, you are right, sorry. It's y minus x. And then I think it's y squared plus xy plus x squared?
Yeah.
Yeah, okay. I gotta remember my difference of cubes. Okay. And this is all equal to 2x.
2x minus y.
Perfect.
And you can move the 2x minus y to the other and you can factor x minus y again. So you would
Right.
just have y minus x times something even bigger.
Mm-hmm. So wait 1 sec. Well, this is basically the same thing as this, but with a negative sign on it, right?
Yeah, so when you move it to the other side, it's just going to be positive in a way.
Got you. Yeah. Okay. So if I move this, then it's okay. Got you. So then, so this is gonna. So I'm gonna say 0 is equal to y minus x, y squared plus xy plus x squared, and I'm gonna say plus y minus x, right? Plus 2y minus x.
Plus 2y minus x, yeah.
Beautiful. Okay. And then I see what you're doing. You're gonna factor out the y minus x. Oh, that's so cool.
Yeah, so you're just going to have 0 equals...
Good. And
yeah.
then it's 1. No, sorry. It's
2.
Y squared plus xy plus x squared plus 2.
Yeah.
Right, good. Is equal to 0.
And that whole quantity is just going to be greater than 0 because it's all pluses.
Oh, true. Yeah, I guess so. Because even if one of the x's is negative, I guess x squared positive. Yeah, is there any way for this to be below? Maybe not, I guess.
No, because x is positive. X and y have the same sign. So even if y and x are negative, xy is always going to be positive.
Oh, sorry. You were right about from this. Yeah.
They have the same sign.
Gotcha. Okay, cool. Okay, so this is always
so
positive.
the only possibility is y is equal to x.
Always positive. Okay, so
Yep.
Y must equal x for this to equal 0. Okay, cool.
Yeah, and then you just have an equation, a system of equations, I think, with not even a system of equations, just a single equation from equation 2. Since you know x is equal to y,
Yeah.
Just y cubed plus 1 is equal to y, and you have a
Brilliant.
third
Okay.
degree polynomial.
Yeah. Okay.
Yeah.
So this becomes y cubed plus 1 is equal to 2y, which is a cubic. I guess it's kind of annoying. Y cubed minus 2y plus 1 is equal to 0. And then...
You can
was like-
find that 1 is a solution, so you
Yeah,
can
y equals 1 is
factor
a solution. Exactly. Right. Yeah, so this is classic. So I'm going to do polynomial division, right? So y equals 1 is
Yeah.
a solution. So y minus 1 is like a factor. So then I can say that...
Exactly, $5.
And now my wonderful knowledge. Yeah, exactly. Yeah. You're right, Fem. So this is equal to y minus 1 times something, and that's where I divide this over to try to figure out what this something
Yeah.
is.
It's gonna be y cubed plus 1 minus 1. Y cubed plus y minus 1.
Let me remember my long division. I guess I could do synthetic, but whatever. Okay. So then this would be y squared, and then that's y cubed. Oh, sorry. I have to put a plus 0 y squared. Oh, this is actually a very fun question, actually. Minus y squared, whatever. That cancels. That becomes plus y squared. And then how many times does y minus 1 go into y squared? Goes in y times. So then we get minus 2y. Then I get y squared minus y. These cancel. I get negative y. So then this is minus 1. And then this is plus 1. And then this is negative y plus 1. And then I get 0. Okay, so then that's y squared plus y minus 1?
Yeah.
Is that what you said?
Yeah, that seems right, yeah.
Okay. Y squared plus y minus 1. And then I guess this does have solutions, right? I could do...
Yeah, it does. I think it does, yeah.
1 plus 4 all over 2. So negative 1 plus or minus the square root of 5 over 2. are the other solutions?
Yeah, that's cool.
Wow.
Close to the golden ratio. Or is it the golden ratio?
Is it the golden ratio? Is that it? 1 plus is square root of 5
I
over 2?
forget sometimes.
It's either it's -1 or it's
Positive 1, I think.
yeah, I don't remember which.
Yeah, it's 1 plus
Either
the
way,
square root of
for
5
sure.
over 2. Oh, wow.
Yeah, okay, so one of them is negative.
Yeah,
Well,
it's
Abram,
close anyway.
you gave me a question with the golden ratio. Oh, it's close. It's close. Yeah, because it's -1, not.
But yeah, one of them's negative of the golden ratio, and then the others, I don't know, just some other shit.
Oh shit. Okay, cool. So there's 3 solutions to these. So we got them. We got, gentlemen, we got them. So
Yeah, and the other solution to this problem would have
yeah.
been
Let's see the easy way.
yeah, without even going into involution, right? Without trying to put in a substitution and getting a systems of equations out of it, or simultaneous equations, you can realize that cube root is the inverse function of the right-hand side.
Oh, that's hilarious. I see
So
what you're
if
saying.
you divide everything by 2, you're gonna have a cube root on the left-hand side and y cubed plus 1 on the right-hand side. The left-hand side is the inverse function of the right-hand side.
Okay. So if I said, like, for instance,
Yeah.
like f of y was equal to y cubed plus 1, right? Then f inverse of y.
No, y cubed plus 1 over 2.
Oh, okay. Sorry, you said move that over. Okay, y cubed plus 1 over 2. Okay, and then if I wanted to solve for the inverse of that, I remember I like. Well, this is weird. I'm used to doing like. Let me just do it this way. F of x.
You can do it. Yeah.
I do it this way. I say like y is equal to x cubed plus 1, and then I swap it, so then it's x is equal. Over 2. Oh, I see. But it is gonna be exactly the same thing.
Yeah.
Y cubed plus 1
It's
over
the same
2.
way. Yeah. Anyway.
Wow. Okay. So then yes, 2x minus 1 is equal to y cubed, and yeah. Wow, it's the same fucking shit.
This is something we do
so cool.
when we're like, this is one of the typical problems we meet in like classical Olympiad problems.
Yeah.
Like having a function inverse equal to its non-inverse, basically.
Okay. Yeah.
When this happens, like just try writing f inverse is equal to f.
Right. So f inverse of y is equal to f of y, basically, at this point. Okay. Cool.
Yeah. So what happens if you apply the function f to this statement?
Oh, interesting. So that would get me y is equal to f of y. Is that what would happen?
Yeah.
Yeah. Okay.
Yeah.
So if I do f of and f of on this one. Yeah, then I get that y is equal to f of y. Okay.
Yeah, but notice now that function f that we have defined,
Yes.
which is y cubed plus 1
Mm-hmm.
over 2, basically,
Right.
It's always increasing.
Correct. Is it always increasing? What if y is negative? Wouldn't it be decreasing?
No, because it's increasing from negative infinity to positive infinity.
Oh, okay. Yeah, okay. Oh, sorry. Yeah, y cubed looks some shit like this. Sorry, you're right. I thought you were saying like it's never negative. Yeah, no, you're right.
No.
It is always increasing.
It's
Gotcha.
always
Yes.
increasing,
Okay.
right? So what does it mean if it's increasing?
Means the derivative is always positive.
Yes. So there is another fact about increasing functions. It cannot have a cycle. It cannot have a 2 cycle, a non-trivial 2 cycle.
Okay.
Do you know what that means?
I have no clue what a 2 cycle is.
So if the function at point y is greater than y, then f of y would be greater than f of y, which is greater than y.
Yes. Okay. I see what you're saying. Like, the function acting on the number has to always give you a bigger number. Because you just keep doing the function.
Yeah, that cannot happen. That just cannot happen.
Like f of y could give me like 8, for instance, and then like f of
Yeah, but-
8 has to give me something bigger than f of y, right? I think. Is that what we're saying?
No, not exactly. What I was saying is that, like, we're trying to get to the fact that f of y is equal to y. That's what
Okay.
we're trying to prove.
Trying to prove. Okay, wait. Trying to prove. F of y is equal to y. Okay. All right.
So
Let me go on. Go on. Go on.
I threw out a word out that I just said a 2 cycle. So a 2 cycle basically means for any function that if we apply, let's say, a function f to two random numbers a and b, right? F of a is equal to b, and f of b is equal to a.
Okay.
So if you apply f again to any of these statements, it just takes you back to, like, it's a cycle basically. If you apply it again, it takes you to a. If you apply it to b, it takes you to
Oh,
A.
this is cool. Oh, I see what you're saying. Right, because then f of b was equal to a, so
Yeah.
this is equal to a.
Yeah.
Oh.
That's
Oh,
that's a
okay.
cycle.
Okay.
That's what you say when you say a function is cyclic.
Is that a 1 cycle?
This is a 2 cycle. A 1
This is a
cycle
2
would just be a function always repeating on the same value. Yeah.
Okay, cool. It is
So
what's a 3 cycle?
and you call a 3 cycle is just applying it 3 times, and you just cycle through 3 values.
Gotcha. Okay. All right. So sorry.
Right.
Keep going on.
And,
All right. So
yeah, and
this
you-
is okay.
You call this cycle non-trivial when a is not b. Logically, because if a was equal to b, then you just have a trivial 2 cycle, which is just a 1 cycle.
Okay. Got you. Right. That would be a 1 cycle if f of a was equal to a. Yeah.
So now, knowing this, can we say about our function that it is
A 2
too
cycle.
cyclic? Yeah.
Let me think.
Can we show that it isn't?
F of A is equal to B. F of B is equal to A. Well, if this is A. Wait, no. Maybe. Trying to think here.
Okay, well, if f of y is greater than y, what happens?
If f of y is greater than 1.
Y greater than y.
Oh, it's greater than y. Okay.
Yeah. What happens?
I feel like the function just keeps increasing, no? F of y is greater than y.
Is it possible? Because what happens if we apply f again?
Okay, and then if we apply, okay, then if I applied f of y, would that be greater than f of y? Bum bum bum. Well, maybe I'm not seeing it. I think maybe, yeah. Could this be true? This is my thought of, like, if it keeps increasing, then this should be true. If I keep taking the function of itself.
Now, f of
No.
f of y, what is that equal to?
Oh, that's equal to y. Oh. Oh, shit.
Oh no.
Oh, no. This was equal to y. But now we say that y is greater than f of y. Oh, that's a problem. I see.
So
Okay.
saying that y is greater than y.
Oh, and this is bad.
See?
Bad. Okay.
The opposite direction.
The
is
opposite's
same.
also true. Right, exactly. Got you. Okay.
Yeah.
So the only
then
solution-
only possible explanation is
Okay.
if it was equal to y.
That's so cool.
Yeah, the way to avoid all of this was just to say happens for any strictly increasing function, right? It cannot be too cyclic.
Got you. Okay, got you. Any strictly increasing function cannot be too cyclic. Okay. Trying to prove. So cannot be. Okay. Got you. Right, okay. So f of y has to equal y. Got it? Okay. What does that tell us? If f of y has to equal y. Oh, so
Well,
then we
can
just have,
solve the entire problem. Yeah.
yeah, and then we just solve this, and then we just say, okay, cool. So y cubed plus 1 all over 2 is equal to y. Bingo bango, we're done. Or we do the
Yeah.
same shit?
This is you can do. Imagine if that cube root was like a sine or a cosine or something that's more difficult to evaluate.
Yeah.
Cannot really be substituted in.
I see. It would be much easier to deal with this side than it would be to deal with this side to solve.
Yeah, so that's when the inverse function comes in.
Wow, that's super cool. Wow, that's super dope. Holy shit. Narosky, how do you know all this math, dude? I feel so dumb. It's so cool. This is the dude. Why don't they teach this in school, man, dude? I feel like kids would think math is cool if they like saw this shit. I digress. Anyways, yeah, cool, great question.
Does anyone else have actual questions? Or...
Does anyone else have actual questions? Yeah, there are 4 questions here. We'll see them coming in. Yeah. Let's see.
I wanted to submit that geometry stuff, but I didn't want to take anyone's place.
No, you can take
I
places.
don't think
Don't
there's
worry.
any legitimate questions.
Yeah,
left.
throw him in, dude. Throw him in, Narosky.
Okay.
Throw him in, dude. Yeah, never worry about taking somebody's place because that's what the bot is supposed to like account for. Where if you submit something that looks really difficult, it'll like lower the priority of it getting asked. But I don't ever want that probability to be 0. Because I have like some kids being like, hey, I need help with easy questions, but you spend too much time on long questions. I'm like, well, but I want to do long questions as well. So the bot is like kind of a, what do we call this? Like a skill-based matchmaking like system or something. Where
A mediator.
Mediator, maybe a moderator, where like just easy questions I can do quickly, it'll prioritize, but it'll still give a chance to like hard questions because I really enjoyed, because this is a great example of actually I don't know, what did this get rated as? Sorry, let me see what rating. This only rated it as a 4 out of 10, which I think is wrong, right? I feel like this is more than I mean, it's a 4 out of 10 question if you just brute force it, I guess, but these tricks here I feel like are more advanced than 4 out of 10. Yeah, Abram says nice solution.
I can give you something that's like a puzzle.
Oh yeah, puzzles are fine too. Yeah, Matt. Yeah, is it like
Yeah.
I like puzzles. Puzzles are fine too. Yeah, give whatever. Abram says
Okay.
nice solution. Good job. Yeah, I'll admit, Abram, that was all Narosky. That was I was just being guided and taught, but like yeah, it was super cool. Let me see what WWW said. WWW said, hi, just joined. I'm not sure what this is exactly, but it makes me think that an intuitive case where this kind of feature is true is probably something like modular arithmetic. Another case could be like periodic functions like sine. However, this looks more complicated than that, so maybe I'm just being a distraction for no reason. No, you're never a distraction. It's okay. Bot is against your questions. No, I'll select them randomly now. Yeah, I'll select them randomly. Yeah, don't worry, Kaushik. Okay. All right, let's go to the moderator, and let's see which question is going to get selected. I think you're probably going to get selected this time, Kaushik. We'll see.
Let's go gambling!
Breasticles only has an 11% chance of getting picked. And it is you! There you go, Kaushik. Oh, this is the vector one. Yeah, okay. We're going to do some vectors. But yeah, WW, I don't know what modular arithmetic is, but it is cool. I mean, having the function equal the inverse, that's something I haven't seen before, and it did have some really cool properties to it. I guess if it's always increasing, yeah, right? The only solution is f of y equals y. That's super cool. That's so cool. The other time to shine problem looks really cool. Interesting. Okay, well, we'll see if we get to it. All right, so let u hat be equal to u I hat plus u j hat plus u k hat. So it's a unit. So okay, cool. It's a unit vector in R3. I don't know what U1, U2, and U3 are. Oh, okay, sorry. If it's a unit vector, that means that the magnitude of u has to be equal to 1. Okay. So if this is true, just right off the bat, I know that the square root of u1 squared plus u2 squared plus u3 squared, this has to be equal to 1 in order for the magnitude of this to also be unit. Okay, and we say w hat is equal to 1 over the square root of 6 I hat j hat plus 2k hat. Okay. I think that makes sense because that would be 1 squared plus 1 squared, which is 2, plus 2 squared. So 2 plus 4 is 6. And then divide by the square root of 6. Oh, and this squares, sorry. So it becomes 6 over 6. Square root of 6, and square root of 6 over 6 is 1. Yeah, okay, cool. Okay, good. That's fine. Whatever. Okay, given that there exists a vector v in R3 such that u hat cross v is equal to 1, and w dot is, I assume this is a dot product here. W dot u hat cross v is equal to 1. Which of the following statements are correct? They're infinitely... Okay, there's a bunch of like answer choices we could do here. Crazy. My gut instinct is to define v as a vector, and then just like do some math and see what happens. Okay, so like let's let v vector equal to like a I hat plus b j hat plus c k hat, and of course that vector doesn't have to be unitary, or doesn't have to be a unit vector, so these numbers can be whatever the fuck we want them to be. And then I want to see what like u hat cross v would be, and more importantly, the magnitude of it. Okay. Maybe v1, v2, v3. Yeah, let's do that instead. I kind of like that. It's, well, actually, I like the ABC because I don't know, v1, v2, v3. I start seeing like too many numbers and stuff. All right, let's just do what the cross product would be. So the cross product of u with v would be u1, u2, u3. Okay, I see why he's saying v1, v2, v3 would be easier. I'm still gonna make it ABC. Okay, and then we cross these, right? I hat, j hat, k hat, and so that would be u2c minus u3b. That would be one component, and then we would minus u1c minus u3a, k hat, and then plus u1b minus u2a, that's j hat. Oh, but then we need the magnitude of that to equal to 1. Okay, so this is equal to u hat cross v. This is where I feel like I'm doing this wrong, because the magnitude of this is going to be ugly as anything. Right, that's going to equal to the square root, we would say like, of this squared plus this squared and then plus this squared. Cool. That all equals to 1. And then we say some vector w. Okay. So then w hat dotted.
I think there's an easier way to find the magnitude of that.
What's the easier way?
So for, at least for unit vectors, the what's it called? The magnitude of their cross product is just the angle between them, or the sine of theta between them.
Oh.
Because we can also define the magnitude of a cross product to be the norm of u times the norm of v.
Correct.
Times sine of theta, and since both of them are unit vectors, then
well,
the
v's not a
magnitude
unit vector.
of it is just sine of theta.
V's a regular vector.
Oh, v, not w.
Bruh.
Yeah, that's the only problem. Right.
We could still write it though as the norm of e times
Let's
sine
do that.
of theta.
Let's do this. No, I agree with that.
A bit easier.
Yeah, so magnitude of like a cross b is equal to, yeah, magnitude a, magnitude b, and then it's equal to sine theta, right?
Mhm.
Yeah. Okay, cool. So this u hat cross v, right? Magnitude of this is just 1, but then we have the magnitude of v, and then we have sine theta. And then this is technically the cosine between these two, but this is like not a very nice, I don't even know what the fuck this vector is, right? Well, actually, wait a minute. Wait a minute. Oh, wait, watch this, breasticles. Okay. But A dot B, right, is equal to magnitude of A, magnitude of B cosine theta. So in this case, so W hat dotted with U hat cross V, right? That's equal to the magnitude of this thing, which is 1, times the magnitude of this, right? But the magnitude of this is just equal to V sine theta, yeah?
Yep.
And then it's times cosine theta.
You probably
And that's all
use
equal to
a
1.
different variable for the cosine.
Oh, you're right.
That
They're
would
two
be the
different
angle
angles.
between-
You're
yeah,
right.
So like cosine phi or
Cosine
something.
phi is equal to 1. Okay, very cool. So my two equations are magnitude of V sine theta is equal to 1. Oh, wait. And then magnitude of V sine theta cosine phi is also equal to 1. So unfortunately, 3 unknowns, 2 equations. Huh. Oh, well, this... whoa. This is already equal to 1. Okay, so that just tells me that cosine of phi is equal to 1, right? Just right off the bat.
Mm-hmm.
So phi must be equal to 0, right? Okay. So that just tells me that the magnitude of V times the sine of the angle in between the two has to be equal to 1. That means there's like a ton of different choices, basically. Right?
I think so. So for sure, A is correct, I believe.
Oh, multiple can be correct here. Okay. There are infinitely many choices for V. I believe there are, actually. Yeah, I do believe this is true. I believe you could pick like whatever. Jeff says, recall that U cross V is equal to 1. So you can find sine of theta. Oh. Yeah. You're right. We did that from here. Oh, no fucking shit. Wait, one sec. Wait, sorry. Magnitude of U cross V is also equal to 1. Oh. Oh, so funny. Oh, wow. So wait a minute. If this is equal to 1...
the magnitude of V would be equal to the cosecant
Oh, it's the same thing.
theta.
One sec. Yeah, wait. No. I don't think we can find sine of theta, right? Can we? Sorry, where are we getting sine of theta? Oh.
I feel like we can find the magnitude of V.
Oh, it's 1 over V. Yeah, sure.
Yeah.
Yeah, sure. Yeah, no, I agree with that, sure. Yeah, either way, yeah, sure. Yeah, sine of theta is equal to 1 over magnitude of V. Cool. All right, cool. So yeah, I think there's infinitely many choices for V. I think that's true. If U hat lies in the XZ plane, then 2U1 equals U3. Okay, this is where things get complicated. Well, we know this is wrong. Okay, so, and then this is what we have to decide. Whether U hat lies in some plane. Oh, damn. I feel like... Oh, okay. So if U hat lies in one of the planes, that means the other component is 0, right? What does that do to a vector? Yeah. I mean, in terms of cross products. Yes, exactly. Okay, cool, Femvox. All right, we'll check it. All right. So, maybe I want to check this and just see what happens, right? Yeah, I feel like that's what I want to do. Yeah, let's do it. And then, okay, this will change something. Because then W is equal to 1 over the square root of 6. Okay, so wait, watch. So this would be equal to 1 over the square root of 6. And then it's going to be all this fucking garbage. And so that's just 1 I hat, 1 J hat, and then there's a 2 here. And then this is all also equal to, also equal to 1. Okay, cool. Okay, so now I think I can maybe solve some stuff. Okay. Okay, so if U is in the XZ plane, then U2 is equal to 0. All right, let's see what happens when we do that. So if I do that, let's see what happens to this. Thank God for copy paste. So let's see. This term goes away. This term goes away. And so I'm left with U3 squared, B squared. This is still going to be a mess. And then plus U1 squared, B squared, plus U1C minus U3A. And wait, I can just square both sides, right? That's all equal to 1. And then what would this thing turn into? Oh, man. So U2 equals 0, so this goes away. This goes away. And I get, oh, sorry, and then these are no longer vectors anymore. It's a dot product. Yeah, let's get rid of this. Okay, so then this is negative U3B and minus U1C minus U3A plus 2U1B is all equal to the square root of 6. Man. I guess from these two things, you'd have a relationship between maybe the A's and the B's cancel out. What are we trying to show? Sorry. Oh, and then we want to show U1 and U2. Wait, what? Oh, wait. Oh, no, sorry. And this one, U1 equals U3. Is that the only way for this to work? If U1 equals U3, this goes away. No, sorry. That becomes... Okay, let's consider 2U1 equals U3. So then I get 4U1 squared B squared plus U1 squared B squared plus U1C minus 2u1a squared is equal to 1. Negative 2u1b minus u1c minus 2u1a plus 2u1b is equal to the square root of 6. Oh man, I don't know. I don't know. It just looks kind of like a mess, dude.
There's a very easy simplification here that you're missing.
What am I missing, dude? Tell me. I don't want to do all
Negative
this.
2u1b plus 2u1b.
Oh, yes. Correct. Yes, you are right. Okay, so this actually cancels out, which is kind of nice. Okay. Oh, wait a minute. So then this, which is this shit, is equal to the negative square root of 6. Yeah?
Yep.
Okay, cool. So then I have 4u1b squared plus u1b squared plus 6 is equal to 1.
Which is also 5u1b squared.
Okay. 5u1b squared.
I think
is
u1 should also be squared.
Yes, u1 squared, sorry. 5u1 squared b squared is equal to negative 5. So u1 squared b squared is equal to negative 1, but that's not possible.
Oh no.
Can't have that happen. Right? I'm gonna say not possible. Okay, cool. So that's not right. Okay. Can I just assume this one works? Because they said multiple correct, and there's no way they would only make one of them correct. I think to do this one, just in the interest of time, just because I'm getting tired, you would have to like do the same assumption here, where you would say that now u3 is equal to 0, go through cancel everything, and then I think show that it works. Maybe it's not the worst thing in the world. Okay, maybe fine. All right, let's just do it. It'll take. I don't think it'll be that bad. Okay. If u hat is in the xy plane, u3 equals 0. Okay. So this goes away. This goes away. And so I get u2 squared c squared plus u1 squared c squared plus u1b minus u2a squared. That's all equal to 1. And then from this one,
I think you could also simplify that a ton because the question asked specifically that u1 equals u2, so you could combine a bunch of terms there.
yes, yeah, we're eventually
By
gonna do that.
writing u1 as u2.
Yep. I want to show that like maybe like it's not possible or it is possible. It's kind of a bullshit like way to answer it because I'm just plugging in the answer to see if it works. I'll look. There's probably a solution somewhere that like does the proper way to do this. Square root of 6. Right, okay. u1 equals u2. What happens? So for this one, you get we get 2c sorry. Yeah. u1's 2u1 squared c squared plus u1 squared b minus a squared is equal to 1. Right, okay. And then this one, I end up getting that these cancel. Love that shit. Okay, so then I get that like u1 b no sorry u1 b minus a is equal to the square root of 6 over 2. These cancel. That I'm going to move over. I'm going to group this. Okay, so b minus a is equal to the square root of 6 over 2, 1 over u1. Square that. U1s are going to cancel. I'm going to get 2u1 squared c squared plus 6 over 4 is equal to 1. I think we have another issue here, right? Because look, 2u1 squared c squared is equal to negative a half. Also an issue. Okay. I think the answer is just A. That's kind of mean, unless I did that wrong. Let's see. I think I had AI solve this one at some point. No, they said D's correct though. Oh, this is so dumb, dude. Dude. Breasticles. We didn't even need to go that hard, dude. We could have just
I was looking at AI.
We could have just fucking looked at this, dude. Okay, so u hat, which is equal to 1, right? Is equal to u1 squared plus u2 squared plus u3 squared, right? But right, if u lies in the xy plane, that means u3 is 0. So wait a minute. That tells me that u1 squared plus u2 squared must be equal to 1. Wait, what is it? What are they doing in the solution here? What are they doing? Silly bitch here, dude. What are they doing? Then u3 equals 0. Using u1 plus u2 plus 2u3 is equal to 0. Wait, where are we getting that from? Oh, Cauchy-Schwarz.
Because u cross v is perpendicular to u, so u dotted with w is 0. Which gives us u1 plus u2 plus 2u3 over root 6 equals 0, which gets u1 plus u2 equals 2u3.
One sec, sorry. Alright, 1 sec. Femvox says your next problem is a winner. Okay. Oh, wait. Oh, okay, wait a minute. W dot that is this. So this must be equal to W? This must be equal to W hat? Is that what we're kind of saying here? It's only possible if... Oh, yeah, see, this part of the solution I didn't get. Yeah, sorry, this part. Okay, u is a unit vector and w is that vector. And we said that u cross v is equal to 1. And w hat dotted u cross v. So u cross v magnitude is equal to 1. That's equal to 1. Let y vector equal u hat cross v. Okay, then the magnitude of y must be equal to 1. Well, that was already given. And w dot y is equal to 1. Since w is also by Cauchy-Schwarz, if the hat with the vector is equal to 1, that implies y vector is also equal to W hat.
Not really sure what they're getting at with Koshi swords.
Yeah, I don't get
think
this part.
the image I sent, I think, makes
Oh, sorry. Let me see.
sense.
Okay, yeah, sorry. Let me see this. I'm not really sure what's going on there. Since both W hat and these are unit vectors, their dot product is 1. Okay, when they only point in the same direction. Okay, I agree with that. Ah, okay. I think I see this. I think I get that. I think I get that now. Because an U cross V is perpendicular to U. Okay. Okay. I get it now. I wouldn't have seen that. Man, it's because there's so many different vectors like going on. There's like a U, there's also a vector V, and then there's a vector W, and then that one's, those two are unit vectors, but that one's not. Okay.
Can someone say 8th dimensional space?
8th dimensional space.
That's what it looks like to me.
Yeah, it's three-dimensional space.
Dimensions isn't.
It's
I mean,
three.
there's infinite dimensional spaces, so.
Okay, one sec. Did they tell us that U cross V? We said the magnitude of U cross V was equal to 1. Oh, okay. So this has to be a unit vector. And so the only way you can have a unit vector dotted with another unit vector equal 1 is if the two vectors are the same.
Yeah.
Did we not prove that from here? Maybe we didn't. What's up, Oh, you know, we kind of did that.
When we said
here.
Phi is equal to 0.
Phi is equal to 0. Right. Oh, well, duh, because that's equal to 1. Nah, but we never said this was equal to this. We never said that this vector was W hat.
I mean, we never directly said it, but if they're
No,
both parallel,
yeah, that's
and they
that's
both
the
have the same
yeah.
magnitude, then they
That's the
won't.
part that messed me up. Okay, I see it now. Okay, so once I know that, if I know that is W hat, okay, and then one sec. That's W hat, and so that means V is perpendicular to U. Or no, U is perpendicular to V. No, sorry. Means W hat is perpendicular to both U and V. So, okay, U dot W is equal to 0. Oh, I see. Okay. And then you get to here. And then we're all easy. Okay, cool. Fine. Okay. Got it. I got it. Dental admission test. Congrats. Is that a good score? I don't know what a 470 means. I didn't know they had dental admission scores. Dental school has scores like the MCAT? That's cool. Okay. Oh man. Oh, I'm tired of that one, I'll tell you what.
I thought you had to study to be a GP before you could be a dentist. Or is that only here?
No, you don't have to go to med school to be a dentist. I don't think so. Maybe if you want to be like an oral surgeon. That's a good question, actually. Hey, wait. No, because dental school is its own thing.
Yeah, that's why I'm asking, because probably not here. I'm
Yeah.
reasonably certain in the UK you have to be a GP before you become a dentist.
Yeah.
I didn't know they had dental school in the UK.
That's what I'm saying.
Oh, no.
See, unlike in America, we take our teeth quite seriously, and so you have to study to be a doctor before you become a dentist. As opposed to in America, where it's just like, fuck it, can you hold 2 tools like a monkey? Become a dentist.
Yeah, he's joking about the fact that everyone in England has like terrible teeth. That's the joke he's making.
Actually, we don't. Statistically, our teeth are a lot better than yours because we don't pay for ours.
I don't know. I will say, I don't know. There's a recurring joke. Maybe in Asia. I think in Asia they don't really care about like. So the U.S. is obsessed by the cosmetics of teeth, not whether the teeth are healthy or not. It's like, are they straight or do they look nice? I think that's what we're talking about when we say like, quote unquote, take care of your teeth. In reality, I think like definitely places like Japan, I noticed that like people didn't have perfectly straight teeth, and it's probably because like, bro, like you don't need to have perfectly straight teeth to like function. It's a vanity thing for sure to like have straight teeth. Yeah. Oral surgeon. Natural, but... Yeah, exactly. It's not natural. Like, yeah, having perfectly straight teeth. I mean, the other thing is like veneers, dude. That's the whole like pandemic thing in Hollywood is no one has real teeth anymore. They all like shave their teeth down to like little shark poles and then they like put dentures on. It's actually terrible, but it looks really nice. Indeed. Okay. Wait, what happened to my screen? Okay. But that's cool. Oral surgeon needs both dental and medical school and residency. That's crazy. I didn't know there was so much work to be an oral surgeon. I guess it is surgery.
Yeah, I've only had to have that done once.
Yeah.
That was not fun.
What did you have to do? You have to have your jaw like realigned or something, or what? Did you punch someone too hard? What'd you do?
No, there's a tooth there which never fell out. I didn't at the time.
So it got impacted or something.
Well, no, it just never came out. Sorry, baby teeth never came out.
Baby teeth. You had baby teeth that never left. Oh wow.
And it became an issue because there was still something there.
Mm-hmm.
Wait, what? Was that the second time? Oh shit, maybe more than once. Anyway, I'm quite big, and we don't use NOS.
Oh yeah, so you guys don't use any sort of
generally
anesthetic.
speaking, we don't use gas and air or nitrous oxide as you'd call it.
Yeah. Whippets.
We inject a numbing agent into the gums.
Novocaine or lidocaine, I think usually.
Something like that, yeah. But it's
or
like because I'm so heavy, it's like 6, 7, or 8 of these fucking things.
Bullshit, not good.
I don't like needles.
That's
needles.
not the problem. No, the injections are fine. I don't give a shit about injections. It's my god, my whole body is just pumped full of this shit. I feel really sick.
Oh, I see. Yeah, your body like you start hitting like the LD50 for lidocaine. You're just like, excuse me.
Oh no.
Sitting there with my face hanging off because it's like.
Proper knacker,
I can't
dude.
talk. Can I have a cigarette?
I can't talk. Alright, we got... What is it? We got how many minutes left? What did I see? I saw 20 on the thing, right? 20. Okay, so we can probably do one more question. Let's see who it's going to be.
Let's go gambling!
That last one took me 30 minutes.
This says they're working in Japan at university to regenerate teeth. Look into it. It's insane. See, I heard that same story 20 years ago, but it was Germany that was working on it. So I don't think anyone's successful.
Regenerating teeth. That's cool.
Yeah, you use a subsonic device to regenerate teeth and hair.
Teeth. I got one. I don't know how to do it though. Like sharks. Yeah, sharks.
My name is Jeff.
Bum, ba, bum. All right, let's see. What's this? This is a derivative. Oh, is this a? This is another. Is this a system of differential equations?
Yeah, it was.
Oh,
it's to prove that they don't all have to be horrific, ugly.
Okay, yeah, let's prove they don't. I like that. I like that.
That,
Yeah, let's do that.
are a pain in the ass to solve.
Okay, so I think the first step on this one was go find some eigenvalues, right?
Yep.
-1, 0, 1, negative lambda. Oh. Ba-da-da-da. You got one, Narosky? Submit it, dude. I might stay extra to go do it. I don't know. I'm feeling generous today. Okay, so this would be 2 minus lambda. Is biopharma medicine using proteins? Probably. I mean, proteins are definitely a medicine. Agree with that. And then plus 1. Oh, and that's all times 1 minus lambda, right? Ooh. Oh, I think so. Wait a minute.
Yeah, that's correct.
Yeah, that is correct, right? Yeah.
Yeah,
okay,
you
cool.
got it.
But then these are all 0. Oh, I'm so happy. Okay, plus minus 0 plus 0 is equal to 0. Okay, cool. So, that's going to be lambda squared minus 2 lambda plus 1. Oh, look at this. This is beautiful because this is already set up for us, yeah?
Yep.
Oh, beautiful. Okay, so lambda is equal to 1. 1 works as well as here, so that's twice degenerate, no?
Yeah, it's just all lambda is equal to 1. All the eigenvalues are 1.
Oh, they're all 1? And what about negative 1?
Yeah. No, it's just 1. Because that factors to lambda minus 1 squared, the quadratic.
You are right, yeah. I'm so silly here. I was like, wait, what multiplies to 1 but adds to negative 2? Negative 1, dude. Yes, okay. Lambda equals 1 equals lambda equals 1. Okay, cool. Okay, nice. Okay, so if they're all equal to 1, then I gotta solve for the but I just solved for 1. Wait, are all the eigenvectors gonna be the same then?
No. There's a method that we do when eigenvalues are all the same.
Okay.
Or well, even if they're not all the same, it's still a method.
Okay, so this is like my first eigenvalue. Let's call it like U1, U2, U3. Oh, okay, so this doesn't really tell me fucking shit all.
And you want that to be equal to 0, the 0 vector.
Exactly, yep. So that tells me 2U1 plus U2 minus U3 is equal to 0, but also that U2 minus U3 is equal to 0. So that tells me U2 equals U3. So whatever, have them equal to 1. And then that U1 must be equal to negative 1/2.
U1 would actually...
No, U1's equal to 0, sorry.
Yeah.
Sorry, what am I saying? Right, yeah, because it's 1 minus 1 is 0. Okay, cool. All right, so then, well, this is kind of a weird eigenvector, but all right, so 0, 1, 1. What do I do to find the other two that are degenerate?
So now we'll say that our vector p, right, p1, 2, 3, is going to be equal to our eigenvector from before. So it's going to be equal to that 0, 1, and 1.
Oh, so you say that this here now goes over here?
Yeah.
Oh, it's kind of like, it's like recursion.
Pretty much, yeah.
Oh, that's so cool. That's cool. It reminds me of differential equations, right? When you have like the homogeneous or whatever is like already encoded in the whatever the general or something. You're like, just slap another x on it. Just keep multiplying by x.
Yeah. I mean, it's basically the same thing.
Oh, very cool. But this there's a problem here. How is... Oh, okay, no. This is all equal to 0. That's fine. Got you. So 2U1 plus U2 minus U3 is equal to 1. And now U2 minus U3 is also equal to 1. Aha! Okay, but if this is equal to 1, that tells me again that U1 is equal to 0. Yeah?
Mm-hmm.
Okay, so then let's say U2 is equal to 2 and U3 is equal to 1. So then 0, 2, 1 is also an eigenvector. Oh, that's fucking cool. And then we're going to slam that thing in over here. Okay. Cool, same thing. 2U1 plus U2 minus U3 equal to 2. U2 minus U3 is equal to 1. So now U1 is equal to 1. Yeah. Right, because, yeah, 2... No, wait, no, I'm wrong. 1/2. Because if this is equal to 1 and I move that over, I get 2 u1's equal to 1. u1's equal to 1/2.
You could
U2
also
equals
make your
to-
life a bit
What's up?
easier if you say that P2 or sorry your U2 from above. If you call that 1 and call U3 0.
Sorry, what? Oh.
If you call U2 1, then U3 is equal to 0.
Oh, you're saying if I call this 1 and I call this 0.
Yeah.
I see. But this technically works, no?
Yeah, technically that works.
Okay. You're right. That would make life easier. Okay. And then I can always multiply an eigenvector by a number, right? So I could just call this the same as 1, 4, 2.
Yep.
Cool. Okay, nice. So then my solution, x vector, right? Is that going to be e to the x times?
It's to the t. Because
it's ddt. Yeah, you're right. Okay, so this is e to the t times this first one, right?
Mhm.
Is it another e to the t, or is it like t e to the t?
Yeah. So what we'll do is that's going to be times C1.
Oh, okay.
And then we're basically just going to kind of like nest it. So our next one is going to be a C2, and then our first eigenvector multiplied by t, plus our second eigenvector all multiplied by e to the t.
Oh, okay. So you're going to say this times t plus our second eigenvector, like this, times e to the t?
Yeah, all of it's multiplied by e to the t. Not
All of
just
it's multiplied by e to the t. Okay. And then wait a minute. For my final act, am I going to do like this t squared plus this t plus the other one?
Yep.
Wow. That's cool. It's cool how, like, I see a lot of parallels to how this works in differential equations, but we just start, like, slapping matrices on things.
Yeah, pretty much.
Yeah, so this is t squared t, and then this is plus this. Wow, super cool. E to the t. Nice. Cool, that's a fun one. I like that the eigenvectors, the eigenvalues were all just 1.
Yeah.
That made me so happy.
It makes it rather easy.
But then this was very cool, how like you have to combine all of them. I will drink some water. Okay. That one only took 12 minutes. What's up, Sam? What's going on, dude?
Oh, yeah.
How's your summer? Haven't seen you in a hot minute. Well, you came by to get your sub subscription. I bought my tickets for TwitchCon today. I will be at TwitchCon. I had a lot of fun at TwitchCon last year. I got to meet a lot of cool people, a lot of cool streamers. Good, nice. It's November, I want to say 13th to the 16th. Yeah. And then, dude, I have to do TwitchCon Europe next year. It's in Berlin. That's gonna be super fun. All right, let's do Neuroskis. We didn't get to do yours last time. Let me go find it. Here it is. Oh, here we go. Something about pyramids. Yeah, Sam, if you're in the area, dude, it's in San Diego. It's not too far. You should come down for at least a day or so. TwitchCon's really fun. It's cool. Cool to meet all the other streamers that we raid all the time in person. All right, the sum of the plane angles. Oh, it is. I know, but I want to do Neuroskis because I didn't get to do Neuroskis last time. Maybe it's good, Shine, if you submit that question next time for whatever the next thing, and it'll be a couple days, and we'll see if I remember. That's always the thing. Like learning something cool in math, great. Being able to remember it is even greater. Like I love that I recognize the trick now, but like will I recognize it later? That's the question. Yeah. Honestly, Sam, I also super last minute. I bought tickets like the week before. I was like, fuck it, let's do it. I'm glad I did. It was really fun. And I think it was very productive. Because now when I go raid a bunch of these people on Twitch, they're like, oh, it's the gold guy. I was like, yes. That is me. Okay, the sum of the plane angles at the top of a pyramid is greater than 100 degrees, then each lateral edge of that pyramid are smaller than the half pyramid of the base. The base is not degenerate, I guess. Not degenerated. Sum of the plane angles. Okay, first of all, what type of pyramid is this, by the way? Is this a triangular pyramid or a square pyramid? Do we know, Naroski?
N-sided pyramid.
It's an n-sided pyramid.
Yeah.
Can we just say it's a
So
cone?
of any.
Can we say it's a cone? So it's an n equals infinity pyramid.
N does not go to infinity.
Because wait, the sum. Okay, sorry. When they say the sum of the plane angles, let me draw like a simple.
So just the sum. Yeah. So if you have like a simple pyramid, like a triangular pyramid,
like this,
the plane angles are just
What are the plane angles? You're talking about these right
the
here.
angles. Yeah, basically.
If the sum of the plane angles at the top of the pyramid is greater than 100 degrees, then each lateral edge of that pyramid are smaller than the half pyramid. Okay. I assume these angles are all the same, right? For a pyramid?
No.
Oh, not necessarily. Oh, okay.
No, because it's like it's any pyramid, you know.
Okay. So we're gonna
So
say
it can be like slanted, it can be anything.
okay. So if the sum of like phi I is greater than whatever, like pi, right? And then let's call these side n. No, not side n. Let's call it side s. Si, okay. Then each lateral edge of that pyramid. Okay. So then I would say, how do you write this in math terms? I think it's like, is this how you say it? Like for every si, for every si such that, I don't know, like si.
No, because so
is less than the sum
for
of
all
SI.
sign. For all sign is the v with the
Oh,
across.
so I have these switched, right? Okay.
So yeah. So what are you trying to say? So for each SI.
I'm gonna say for all si, every si is less than the sum of all the si's over 2, right?
Oh, so just the comma.
Oh, that's all I have to do. Okay, there you go.
Yeah.
I'm getting better at my set notation. You're okay, Femvox. You didn't jinx it. Okay. I feel like when I see stuff like half perimeter and whatnot, I start thinking of like Huron's formula. Right? Because this has to do with the half perimeter, right?
Yeah.
But how do I prove that? I wonder what's the secret behind Gold Guy. Any special reason? I know who the Gold Guy is. All right.
So the problem is like I don't know how to do this.
It's okay. I don't know how to do it either, but we can figure it out. Or
Yeah,
last minute,
but
last
my-
resort,
my-
I can ask ChatGPT.
Yeah, the one thing I try to do,
Mm-hmm.
since I don't have access to chat anymore,
What do you mean you don't have access? Did you cut yourself off? How do you not have access?
No, I just didn't pay for like a while.
Oh,
Yeah,
it's
no,
basically
I'm
free
not
though.
using.
I feel like it's free. I'm glad you're not. I mean, like,
I don't think it's.
It's the equivalent to like watching
useful.
porn. You know, like you're just screwing yourself. Look at this.
I don't
Narosky
have
gets a
any,
girlfriend and he doesn't use ChatGPT. You're like the alpha Chad, dude.
Oh yeah.
Okay.
Yeah, my first instinct was to, you know how you, let's say you have a problem where you have to find the way an ant goes, or maybe a particle goes around a cube or a sphere, and you have to find the best trajectory or something.
Sure.
You know, in that case, you have to like take apart the 3D object and like
like fold it out, right?
Yeah, I'm not sure what the word is exactly in English.
Unfold.
Yeah, I think like you just consider the layout if you make a cut along the lateral surface.
Mm-hmm.
So just
Alright, so let's think about that.
basically
So-
take it apart on the lateral edges.
So like this
know?
would become
Just triangles side by side, basically.
Yeah, a bunch of well, like this, I guess, right? Kind of what it would look like.
Yeah, basically.
Okay, cool.
Yeah.
And we're saying, oh, okay. And wait. And these are angles, right?
Yeah.
Now here's my question: is this going to be exactly parallel with this? Not necessarily, I guess. No. Yeah, no. Yeah, okay. So I can't assume this is parallel with this. Or can I? Huh? Oh.
Well, you can choose, let's say, it's simpler if you just denote it as something. Just call the vertices something in the original pyramid, so I can tell you what my idea is. Because I can't really, I don't really have anything to show you with.
It's okay. A, B, C. Call
The
this
vertex
A,
as well.
B, C. And then, sorry, you want this labeled as well?
Yep.
Okay. Let's call this like X, Y, Z. Okay.
Wait, why X, Y, Z?
I don't know. Just I wanted ABC for the base and XYZ for the tops.
Okay.
Right?
Anyway, it's the same vertex. That's why I asked why different.
Oh, because the angles are
Yeah,
different.
that's what I was.
This angle's different than this angle, though, right?
Yeah.
You are right. They are the same points technically, but okay, sure. Yeah. No, you're right. You're right. I was gonna go off of like, cause I was gonna get lazy and call it like angle X, angle Y. I hate doing like angle CXB. I'd be like, oh, I just don't want to deal with that. But it's okay. We can also label this as just like angle 1, angle 2, angle 3. That's okay.
Yeah. Now imagine instead of just like taking it apart as you did, like just unfolding it basically on each side. Imagine choosing, let's say you're choosing the side XA, right? And unfolding it laterally towards you, like you're ripping it from its side, pulling it towards you. You know what I mean?
Okay. So I'm taking this and I'm pulling it this way.
So instead of just having it unfold in like 3 different triangles, you're just gonna have 3 triangles that are basically connected side by side to each other.
And I'm ripping them apart.
So
like I'm taking this and
I can
I'm connecting it this way. I'm like taking this one apart, connecting it this way.
Oh wait, I can't share my screen.
Oh, it's okay. I can stop sharing my screen. There you go. Try sharing.
Oh, that was okay.
Because I think only one person can share their screen on the stage at a time. That's why.
Yeah. I didn't realize. Yeah, so instead of just like having, 1 second, let me have the same configuration as you. So instead of just unfolding it from the vertex, instead, just like pull this side from the back, just pull it like this.
Okay.
Right? So instead of, so let's say this is A, B, C, and you said X. You'd have something as like X in the middle, and then let's say this is A, then you're pulling B
okay.
here.
Got you.
You're pulling C here, right? And then there's another
Thing that's just dangling off.
Yeah. Let's say A prime, because it has to like be 3. So this angle and this angle is the same. You know?
Okay.
And let's say you have like n of these. So instead of ABC, you have A1, A2, A3, A4.
Mm-hmm.
That's what I was thinking about.
That's a cool way to think. Yeah, you're thinking about instead of unfolding it from the base, you're unfolding it from the top.
Yeah. You can share if you want.
Okay. Try it again. Okay, so mine was that. So then I think mine would look like, sorry. This. Okay, this center thing would now be X. Let's call this X. This is X. Alright, okay, cool. Okay, so then this, and this, and this. And then if I separated it, right, and then this one would be off as well. Okay, so then this is now A, C, B.
That one is also A.
Interesting. Why is this one also A? Oh, it is also point A. Sorry, right, because it came from this. Because it came from this point.
Yeah. Because you're splitting it from that.
From
part.
A. Got you. Okay. But this angle, I don't think equals this angle, does it?
Why not?
Because this angle.
Oh yeah, sure.
Refers to this, right? This angle refers to like this part.
Yeah.
You're right. It's the same point. Okay. And now in that case, go on.
Exactly, and notice that XA and XA prime are basically the same distance.
Yeah, yeah, I agree with that. Okay.
It's still the same. It's still the same side.
Mm-hmm. And now, this is angle 1. This is angle 2, and this is angle 3.
Yeah.
Okay.
So you just basically have a contour of the base, and this base, basically this contour we have ACB A prime is basically the perimeter of the base.
Correct. Okay, got you. Yeah.
So if we extend this to like the actual question,
which is an n-dimensional one.
Yeah, you'd have like n of these just spread around like in a polygon type stuff.
Yeah.
These sides just equal the perimeter. It's saying that if
it's saying if this angle is greater than 180,
yeah,
yes,
or greater than 180.
Okay, so if this like becomes more than a straight line from A to A prime, then any one
of
side,
the sides, XA, XC, XB, X, whatever,
has to be smaller than the half perimeter.
Yeah.
Yeah. Oh, sorry. This one. So any of the sides, wouldn't be XA.
Lateral sides.
Oh. So lateral edges doesn't mean the base edges. It means these edges.
No, that's why it's specified lateral edges.
Oh fuck. Okay, that's cool. So in this case, right? this edge is equal to this edge, right?
Yeah.
This edge is equal to this edge. This edge is equal to this edge. I see.
Yeah, and in the other case, we have a double A instead of a triple C, triple X. Sorry.
Got you. Okay. But then the perimeter still here is ACBA, right?
Yeah.
Oh, okay. Yeah, so the 180 degrees doesn't make as much sense here. I agree, Narowski. This is a smarter way to break it open. I'm just wondering what that tells me about... what this tells me about these. Because depending on the number of sides, even if it's greater than 180, that doesn't tell me whether any of these triangles are acute or obtuse or anything. Okay. I see the 180 part, but how does that prove the lateral sides? Have to be less than half the perimeter. And then it's like, it's half the perimeter. Because I was trying to think if it was something like, because this is the path you need to take. So you can make some argument that like doing this. But no, no. But
Yeah, I know what you're trying to say, like doing that doubles the distance or something, but
right, yeah.
Well, like in this simplified case, where we have just like three points on the base.
Yeah.
We did draw it like a bit close to 180 degrees, but I was going to say that on the cutout line, ACBA prime, there has to be a point where the angle is exactly equal to 180. Because if you're a bystander in point X, looking at the line, let's say you're in point X and your friend is going along the sides ACBA, at some point, like you're gonna see your friend go over 180 degrees in the question statement. So there's gonna be a point where he goes exactly 180 degrees.
Okay, sure.
Right? So basically, at that point, A, X, and that point are linear.
Yes. At the exact, if it's exactly 180, then right, yeah, this and this are going to be collinear, correct?
But how does that help us?
I don't know. It's cool. You're like knocking at all the right doors. We just haven't found the one that opens it yet. Oh, Adam says too much aura with the tank top gold chain.
I found a way to knock at that door, but I don't know.
Are we on the right track? What does ChatGPT say? What's the door we should be knocking on?
Honestly, I'm not really sure. It didn't give me any images of what the hell it's doing. It just did a bunch of proofs.
Oh, ew.
Though I guess it is possible, according to chat, the law of cosines, but it could be
law of cosines. Oh, okay.
Well, yeah. So that was my first idea. Was like a system of equations with law of cosines, and it says it's possible, and it gave me a proof for it. But it's talking about like do this with different angles and shit, and it doesn't tell me what those angles are. It's clear, but then also it did some other shit.
Oh, okay. Wait. Narowski, right? Because if we were to use law of cosines on these angles, right? So, for instance, like, I could say that AC squared is equal to, like, this lateral edge plus this lateral edge, right?
Yeah, I mean, it's probably not a very efficient method, but, like, that was my first thought was, okay, well, we can for sure figure out what our perimeter is from our angles if we just, like, brute force the ever-living shit out of the system of equations.
The problem is it's for an n-sided thing though, right? Because then it becomes an n-dimensional systems of equations.
Yeah, I mean, I didn't say it would be an easy system. I just said it would be a system.
Do you see saying, Narosky? Like, you could write this, right, for just this one. You could write for this one. You could write for this one. And then you could probably do some shit where, like, you add all these up and divide by 2. And you add up the square root of all these.
Yeah, here, let me share the chat.
Yeah, send me the link. I'll pull it up. Whatever this nonsense is, dude.
It gives a first solution, then it gives
this nonsense is, dude.
Cosines like I had asked.
I love that you put extended on it. You're like, yo,
oh, yeah.
fucking go for it, dude.
I always use extended.
You're like, yo, dude, fuck the Dolphins. It's a bad rabbit hole. This piano has a much cleaner geometric idea. Unfold the lateral faces into the plane.
Okay. Yeah.
Let S be the apex. Okay. And write that. Fix the lateral edge SA naught. Write SA naught is equal to L. Cut the
so
pyramid.
It's basically doing what we did.
Yes. Okay. So there's the chain, right? Where AN is a second copy of A0. Sure. So SA0 is S. Sorry, what is S? S is the side. The side. Yeah, right. Okay. Or the apex. Sorry. Okay. The angle swept out from SA naught to SAN is exactly the sum of the angles at the apex. Okay. Angle A naught.
Yeah, it's basically saying what the problem is stating.
Okay. Call that point Q.
Yeah.
Okay. A naught to Q is greater than L plus Q. This inequality is strict because the pyramid is... Okay. By the reverse triangle inequality. Oh, okay. Okay, so P is equal to L plus Q minus L. But L plus Q, absolute Q minus L is always greater than 2L. So P is greater than 2L, and thus SA naught is greater than P over 2. And SA naught's an arbitrary edge. Oh, that's cute, because you can just pick any edge to be the lateral edge that you look at. Oh, that's cool. I think you were onto it, Narosky. You're talking about, like, hey, right? If it is greater than 180. Sorry, so if we drew it like this, right?
Yeah, because the way I was thinking was like, I was giving that example with the bystander, because you're basically waiting for your friend to pass past 180 degrees.
Yeah.
Right? So at that point, he has already gone like half the perimeter, basically. Surely, yeah, he has to have.
That's
what I was going.
He's almost done all of it, right? Yeah.
Not necessarily, but yeah, it depends on how many points you put.
Sure. I see. And then this is the Q minus L they talk about. Okay.
Yeah.
Okay.
Exactly.
Cool. Oh, yeah. Okay, I'm tired. That was cool though. What's up, 1K? All right, cool. Let's close out the stream. All right. Thank you everyone for coming to Actual Education Office Hours. Appreciate all the questions. This was a fun one to work through. I always love watching how minds just attack problems. I think there's beauty in it, and you have some very unique way. You have good ideas, Narosky, on how to attack problems. It's pretty cool. Okay, let me add that one. My chat thing did think that was an 8 out of 10 question, so it was correct on that. Nice. Okay, cool. Let's see. In terms of streams, let's go to the streaming calendar. What's happening this week? Where is it? Nope, that's our website. Where's my calendar? Wait, Aura. You know, aurum in Latin means gold. Anyways, yeah, good to see you, 1K. Bye. No, come by one. So come by. Tomorrow we're gonna have a chess tournament. Tomorrow. There's actually a lot of fun stuff going on. Penn Center's doing abstract algebra. Then he's doing real analysis. Zach is doing his trivia game. And then we'll be doing a chess tournament afterwards. And then next Sunday, at this 5 to 7, we're gonna participate in this Summer of Math exhibition, and we're gonna judge some submissions to this three blue, 1 brown, 3 brown, 1 blue, three blue, 1 brown, I think, YouTube channel. So it'll be fun. So yeah, come on by. It'll be fun.
The bot is kind of tweaking. I'm not gonna lie. As a test, I was curious and I told it. I put in a picture and it said solve the Riemann zeta hypothesis. And it says it's real analysis. And it also says the estimated time in minutes is half a minute.
Yeah, I don't think that's true.
But it claims that it's a 10 out of 10. So
I mean, the Riemann zeta is a 10 out of 10.
That.
At least it's right on that. All right, let's go raid somebody. Who are we gonna go raid? I'm gonna go say hi to. Boy, so many people. Software development, Arduino. Dolly Parton cookbook. Oh, that's interesting. Someone's just cooking. No, I know some of these people. Oh, you know what? Someone was doing CAD stuff, right? Someone was asking about CAD. This guy's doing CAD. Go say hi to Uwu's lab. This guy's hilarious, dude. He does like a ton of funny shit.
Yeah.
Okay, but anyways. Enjoy the rest of your week. We'll see you for chess on Friday. Otherwise, we'll see you on Sunday. Peace.
Alright, let's see what this cut rate filament is able to do for us. Hopefully I don't get burned on this like the last time. CAD! Yo, actual education, thank you for the raid. Welcome in. Welcome, welcome. Ghostbusters is a hornier movie when you give it a second watch as an adult. Doesn't a ghost suck a guy off in that movie? Was it ever that subtle?